We're looking at limits that do not exist, and in this segment we're going to look at limits that do not exist because their answer is a type of infinity. So for example, if we look at the limit as x goes to 0 of 1 over x squared, we can see that if we plug in 1 to that, we get 1 over 1 squared, which is just 1. If we plug in a half, we get 1 over a half squared, which is going to give us 4. If we plug in a tenth, we get 1 over 1/10 squared, which is going to be 100. If we plug in 0.001, we're going to get 1 over 0.001 squared, which is equal to that's going to give us 1,000,000. And if we plug in negative 0.001, the negative sign, when we square the bottom, is going to become positive, so it's also going to give us 1,000,000. And so what it looks like here when plugging in nearby values is the smaller number we plug in, the closer we get to 0, the bigger 1 over x squared becomes. And so what we want to say is that this limit goes to infinity because it gets bigger and bigger and bigger. Now, infinity is not a number, so the limit doesn't exist. But saying infinity is more specific than saying it doesn't exist. So if we're kind of making a Venn diagram here of all the kinds of limits that do not exist, limits that equal infinity and limits that equal negative infinity are special kinds of do not exist, meaning that you want to actually give, if appropriate, the answer of infinity or the answer of negative infinity. But for any kinds of theorems or any kinds of rules that we have about limits not existing, these count as kinds of not existing. And if we look at the graph of our function, we can see that, yes, it looks like it's going up to infinity.